Test series 1, question number 30. The question is about rotating magnetic field of an induction motor. The rotating magnetic field of an induction motor is caused by time varying voltages in each phases. Let us consider three time varying voltages VR, which is equal to Vm sin omega t, Vy equal to Vm sin omega t minus 120 degree, and Vb equal to Vm sin omega t minus 240. So we will consider some angles and see how the behavior of the rotating magnetic field is. At omega t equal to 0 degrees, Vr equal to 0, Vy equal to minus root 3 by 2, that is 0.86 minus 0.866, and Vb equal to root 3 by 2, which is 0.866. So if we consider the distribution in space like this, we have Vr equal to 0, so there will be no element in the R axis, and Vy equal to minus root 3 by 2. Vy equal to plus root 3 by 2 is this direction, and Vr equal to minus root 3 by 2 is this direction. So we have Vy equal to, we are first considering an R, considering a R, Y, B sequence. So Vy equal to minus 0.866 will be in this direction, and Vb equal to plus 0.866, that means it will be in the normal direction as this. So when you take the resultant of these two vectors, you will get it as a vector which is having 1.5 times the magnitude as that of the original. That is, when you take the vector sum, you will get 1.5, parallelogram method, you will get 1.5, and it lags Vb by 30 degree. So this is the case at omega t equal to 0. Now let us consider the case when omega t equal to 30 degree. So Vr equal to 0.5, Vy equal to minus 1, and Vb equal to 0.5. So let us consider the phasor and see how the resultant magnetic field is like. So Vr equal to plus 0.5 will be in this direction, and Vy equal to minus 1 will be in this direction. Vy equal to minus 1 will be in this direction. You can note that I have drawn the magnitude of the vectors as corresponding to the length, the length of the vectors as the corresponding magnitude of the vectors of Vr, Vy and Vb, and Vb here is plus 0.5. So this is Vb. Now we can see the resultant is, when you take the resultant of these three, it will be having 1.5 times, and it will be in the direction as that of minus Vy. So this, and you can see the vector, the resultant vector has rotated by 30 degrees in the positive direction as from when omega t was 0. So when omega t was 0, the resultant vector was in this direction. While when omega t equal to 30, the resultant vector is rotated by 30 degree in the positive direction. So, and when omega t equal to 60 degree, when we consider omega t equal to 60 degree, the value of Vr, Vy and Vb are respectively 0.86, minus 0.86 and 0 respectively. So when you take the resultant, you will get it as again like this. This is Vr and V minus Vy, and the resultant is like this. So we will get, this is the resultant, V resultant, and this is also having a magnitude of 1.5. So again you can see that the vector has rotated by 30 degrees in the clockwise direction. So the vector which is rotating clockwise in and having a magnitude 1.5 is the resultant magnetic field. So the resultant magnetic field is moving from leading phase axis to lagging phase axis. That is here, which is the leading and lagging phase axis, we will see. Suppose if this is R, then here there is Y phase and B phase. So B is the for the time varying magnetic field, the B is the leading phase, while when you see the resultant magnetic field, the magnetic field moves from the leading phase vector, that is from phase B to phase R, that is from leading phase axis to lagging phase axis. Here the movement considered for these three angles, that is omega t equal to 0, 30 and 60, you can see that the resultant magnetic field vector has moved from B phase to R phase, that is from leading phase axis to lagging phase axis. So the correct option is option A.